Okay, in this short video, we're going to talk about a concept called mole ratio and how we use it to study acids, bases, and how they react. So, really, what we're going to focus on is the reaction part of that question. So, the idea we discussed in our previous video was balanced equations. So, the coefficients of an equation describe how many of each substance are needed for that reaction, and those coefficients are actually ratios that we can use to determine how much of each substance are going to be needed for the reaction. So here I have a reaction between silver nitrate and copper, and I've gone ahead and balanced it for you. So this balanced equation actually tells us a ratio of silver nitrate to copper nitrate to silver. So if I have two silver nitrates, for every two silver nitrates, there's going to be one copper. And for every one copper, there's going to be one copper nitrate. And for every one copper nitrate, there's going to be two silvers. So here you can see we're using the ratios as coefficient, we're using the coefficient as ratios of the substances for a balanced regular reaction. All these substances need to occur in this ratio in order for the reaction to occur. So these ratios, knowing the ratios of substances allows you to predict how many of each substances will be produced or how many of each substance will be needed. So if I have 10 silver nitrate substances, how many copper nitrates will be produced according to the following equation? And this is just the equation we used on the last slide. So pretty straightforward. If I have 10 copper nitrate for now we're going to use the word molecule. It's not entirely certain, or correct, but we're going to use the word molecule for convenience. If I have 10 silver nitrate molecules, okay, I'm going to set up a ratio, a proportion kind of equation where I put the ratio of silver nitrate that I get from the equation on the bottom. Okay, because when I set up this proportion, you may remember from earlier science classes, I always put my given unit on the bottom of this proportion. And then I put whatever my wanted unit is on top. So in this case, I want to figure out how many copper nitrate molecules are going to be produced. And I get the 1 from the equation. Now, since there's no number in front of copper nitrate in the equation, we can assume that it's 1. So to solve this, I just multiply these fractions together. And what's going to happen is the silver nitrate units are actually going to cancel out. So I basically get 10 times 1/2, which equals 5. And that tells me that I'm going to produce 5 copper nitrate units. Now, the reason we're building up to this is that instead of counting out individual molecules, we use moles. Since a mole refers to a number of particles, the coefficients can be interpreted as moles of a substance. So back to our equation of silver nitrate and copper. Those coefficients can be interpreted, instead of saying 2 silver nitrate molecules, I can say 2 moles of silver nitrate and 1 mole of copper. 1 mole yields 1 mole of copper nitrate and 1 mole, or 2 moles of silver. Now, let's go ahead and use this mole idea in practice. So if I have 8 moles of silver nitrate, okay, and remember, a mole is 6.02 times 10 to the 23rd power, so this is a whole lot of molecules. So we've got 8 moles of silver nitrate. How many moles of copper nitrate will be produced according to the equation that we've been using? So I set it up similarly where I've got 8, and there should be a mole there. I'm sorry, I forgot. There should be 8 moles of silver nitrate. I set it up the same kind of proportion that I did on the last slide, the way I've been doing all year. But now, instead of writing 2 silver nitrate and 1 copper, I write 2 moles of silver nitrate and 1 mole of copper. Now, it is common among students who are first learning to do this to ignore writing the unit. It is not scientifically correct to ignore the unit, because when we start putting all these together, it will be hard for me to identify where you had trouble if you don't put the unit. So please put the unit until you get sufficient enough, or you develop sufficient enough skill to be able to do this. Okay, so you'll notice we set it up the exact same way, except we're including moles, because now we're using moles to count particles. Okay, and we get that number, the 1 and the 2, from the equation. Okay, and they still cancel out, and I get 4 moles of copper nitrate. So that's a basic introduction to how we use Moses ratio. This is something we're going to practice for a long time uh, as part of a concept called stoichiometry. So if you have questions, please ask, and I hope you have a great day.